Hello everybody, Mr. McVeigh here. Today, what I have for you is another video on transformations. In a previous video, we did some transformation work where we just took a parabola or quadratic function and we translated it by moving the vertex up or down or left and right with h and k. Today, I want to continue that video with stretches and compressions. As a quick reminder, this is the parent function of a parabola, y equals x squared. There's usually an a term here, and in this case, our a is equal to 1. And this puts us at the vertex. This puts the vertex at the origin. And I've went ahead and plotted this parabola already, but if I plug some values in, if I plug 0 in, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. If I'm going the other direction, since it's symmetrical about the y-axis in this case, the negative values would be also 1, negative 2 squared is 4, and negative 3 squared is 9. And you can see that I've plotted this function. Okay. We're going to be looking at this function as it relates to, in this case, the vertex form, but in our case right now, we're just going to ignore the h and k because we know how it shifts left and right based on h and k. The vertex we know, the vertex is at h and k. We know this, and so we're going to ignore that right now, and we're just going to look at it in this form, a simple form where a x squared, okay? So we're talking about stretches and compressions. Okay, what I mean about stretches and compressions is we would have let's say we plotted our parent function, parabola here, and let's think of it like we're a jump rope and we're standing on this jump rope and we raise our hands up holding the two ends. If we stretch it, it gets taller and skinnier. We stretch it, it gets taller and skinnier. And if we do a compression would be fatter and wider. Fatter and wider. So this is the parent. This is a stretch. And this is a compression. Okay. Now I'm going to show you a couple rules how to know which is which, but I want you to understand how to do this without actually knowing the rules. I want you to know how to figure it out on your own. And this is why I've created this table right here. I want to do this. I want to do a function, our parent function, and then I want to graph y equals 2x squared. And finally, I want to graph y equals 1/2 x squared. And that's why you see these entries in my table here. Okay, so let's look at 2x squared. We know that x squared is 9. So if I multiply that by 2, I know I have 18. And if x squared is 4 from my previous function, then 4 times 2 is 8. 1 times 2 is 2, 0 is 0, and then it's symmetrical, so we just go back the other way. 8 and 18. Now, if I was to plot this, I'm going to plot this one in red. I'm going to plot this one in red. And what you'll see is a stretch or a compression. Let's see which one it is. Okay, so at 0, I get 0, so that stays in the same place. At 1, I get 2, so here at 1, I get 2. It's symmetrical, so both sides. At 2, I get 4. 1, 2, 3, 4 over 2. I'm sorry, at 2 I get 8. That is right there. And then I got a symmetrical one. And then at 9, I get 18. Or at 3, at x equals 3, I get 2x squared is 18. And so at 3, 1, 2, 3, that's way up here somewheres. 1, 2, 3, that's way up here somewhere. And then I can sketch my parabola through these points. And what you'll see, it's taller and skinnier. So when we multiplied by a value bigger than 1, this is 1, we multiplied by a value bigger than 1, it got tall and skinny. Now let's go the other way and multiply by half. Let's take halves, okay? So at 0, we still have 0. At x equals 1, we have 1 squared is 1. Take half of that, that's a half. 2 squared is 4. Take half of that, that's a 2. 3 squared is 9. What's half of 9? 4.5, so 4.5. And then the other side is symmetrical, so we're going to copy that down. Now let's plot it. Okay, so at x equals 0, I have 0, so the origin's still there. The vertex is at the origin. At x equals 1, I get a half. At x equals 2, I get 2. One there, one there. At x equals 3, I get 4.5. That's 1, 2, 3, 4.5, somewhere's about right there. And then I got the symmetrical one. And you can see what's happening. It's getting wider. That's compressed. So this is compressed. This one is stretched. Okay. So you can see as we multiply, if you figured this out already, if you multiply by a number bigger than 1, it stretches it. And if you multiply by a number smaller than 1, it compresses it. And so here's the rules. We just stated it, but let's say it again. Okay. For A, I'm going to say the absolute value of A greater than 1, we have a stretch. I'm going to say for the absolute value of A less than 1, we have a compression. Now, why I say the absolute value is because this could be negative. Okay, I could have a negative A. In that case, it's a flipped, and it would be opening this way. And so we want to use the same stretch or compress theme. So we just say whether it's negative or positive, it opens up or down. It's still, if it's greater than 1, the absolute value, it's a stretch. If it's less than 1, it's a compression. Okay, that is all I have for you today. If you like this video, please subscribe. As always, have a nice day. Mr. McVeigh, out.